Folks, welcome back to our third and final video over Class Notes 2.3. In our first video, we did a quick review of the difference between mixtures and pure substances, and we also introduced what homogeneous or homogeneous mixtures are. In the second video, we focused entirely on the types of heterogeneous or heterogeneous mixtures. And finally, in our third video, we will be discussing ways to separate mixtures. And this can be done physically because mixtures are just substances that have been placed together. They are blends of substances. They have not joined chemically, so we do not need to undo a mixture chemically. We can do it physically. One of the most common ways of separating mixtures, especially in chemistry, is the use of filtration. Many of you are familiar with filtration. That is very useful at separating solids that are within liquids. And you trap the solid in a filter paper, and then the liquid goes through the filter paper. As mentioned, filtration is useful for separating mechanical mixtures and suspensions. Filtration does not work for colloidal mixtures because the particles are so small they go right through the filter paper. Likewise, filtration cannot be used to separate solutions because solutions it's a homogeneous mixture where we have perhaps salt dissolved in water. The water pulls apart the salt crystals, and the ions in that salt are so tiny they go right through the filter paper. Let's take a look at a little film clip here on filtration. Notice the way she folded that. You fold it in half, you fold it in half again, and it's a nice cone shape. That's the filter paper. Notice the filter paper is below the level of the funnel. It goes all the way through. This is the solution that she'll be filtering. The residue is the stuff that is trapped in the filter paper. The filtrate is what goes through the filter paper. There you go, filtration. The next type of next method of separating mixtures is called decanting. This is very useful for separating mechanical mixtures where we can pour a liquid away. We have a solid within a liquid and we can pour the liquid off, leaving behind the solid. Decanting. Oh, here we go. You see the liquid? And there's the solid. And she's going to pour off the liquid. Oh my gosh, this is called decanting. Actually, this is important what she's showing you here. If you notice a beaker, this is a beaker right here. A beaker has a beak on it, which is a very spout, very useful for transferring liquids. So they put that little spout on there, or a beak. Now, to decant something, she's putting a stirring rod over the top of the beaker, and that will allow that water that's being poured off to be directed. That's decanting. A third method of separating mixtures is called distillation, and this is separating substances based on differing boiling points. Now, distillation takes advantage of the fact that every substance has its own unique boiling point. So if we have a mixture of substances that have uh, different boiling points, we can begin heating it up, and the one with the lowest boiling point will begin boiling first and change to a gas. And that would leave behind the other substance which has the higher boiling point. Distillation is a very commonly used practice in chemistry. Let's take a look at what distillation looks like. It can be used for separating liquids from liquids, and then there's types of distillation where you can separate gases from gases. A fourth one is called chromatography. In chromatography, we separate mixtures based on the retraction to both a solvent and a medium. We have a whole lab that we'll be doing day after, or in our next lesson. We have a whole lab that we'll be doing on chromatography, so we're not going to talk too much about it. A fifth way is called crystallization. This is where you separate solutions based on the solubility of the solutes. So in other words, we have something is dissolved in something else. And when we have multiple things dissolved in substances, each substance has its own ability to dissolve. So different salts or different sugars or whatever have their own solubilities. And crystallization takes advantage of the fact that different substances have better abilities to dissolve. Let's take a look at how crystallization works. the process of getting something to crystallize from its hot saturated solution. So when you have substances that are dissolved in water, you heat that water up, that stuff has been dissolved in there, and now the process of crystallization is getting it back out of solution. Oh yeah, here we go. Mm, that's copper sulfate. It's a blue crystal. Heating it will make it. Oh yeah, and that's super saturating that solution. Get ready for this. Oh my gosh, there it is. There it is. So he dissolved the salt, he heated it up, dissolved the salt, and when it's allowed to cool, it'll crystallize back out. That's crystallization. Sort of like how you make rock candy. If this discussion of separating mixtures physically is not intriguing you, amazing you, making you wondering why this is not up for an Emmy, an Oscar, or something like that, I completely understand. Because we are now down to our final way of separating mixtures called a centrifuge. A centrifuge works by separating mixtures on their density. Centrifuge are those things that spin around real fast, and the more dense materials are drawn away. I think that's a tube of blood. Centrifuges separate the plasma, the solid part, from the blood. There's the centrifuge. Why aren't you wearing gloves? You're dealing with blood products. Where's your gloves? Do you have safety goggles on if it breaks and gets in your eye? And she's spinning it, spinning it. And let's see what we have. Oh, yeah. Oh, yeah. What happened? Let's see. Oh, and there it is. Separates blood centrifuge. Thank you for watching.